Welcome to this explainer. Today we're using geometry to map the universe's totally invisible forces.
So, let's dive right in. How do we actually calculate an electric field in empty space? Imagine catching glowing neon light rays in a giant transparent net. That right there is electric flux.
Mathematically, flux just measures exactly how many of those invisible field lines pierce a given area.
Back in 1835, Carl Friedrich Gauss proved this net outward flux directly mirrors the totally enclosed charge.
It's incredibly elegant. The total flux just equals the enclosed charge divided by the electric constant.
But here's the ultimate physics superpower. This equation lets us completely bypass crazy complex calculations. To use it, just identify the spatial symmetry and wrap it in an imaginary Gaussian surface.
We generally compare two primary spatial patterns to make this work: spherical and cylindrical symmetries.
Let's see this in action. Imagine a single-point charge radiating outward into empty space.
We perfectly wrap this central charge inside a totally transparent 3D spherical Gaussian surface.
Because of perfect spherical symmetry, every single field line hits our sphere at exactly 90 degrees.
The electric field is constant everywhere on that sphere, making the resulting math incredibly straightforward. Now, let's totally shift the scene to an infinitely long charged wire, glowing in the void.
A spherical net won't work here because the electric field pushes straight out from that line.
So instead, we draw an imaginary cylindrical Gaussian surface, perfectly centered right around that infinite wire.
Notice how the field lines now only pierce straight through the curved side of our cylinder.
The field actually runs parallel to the top and bottom caps, so zero flux passes there.
By exploiting this symmetry shortcut, we easily determine the field using the wire's linear charge density. The crucial takeaway: Gauss's law brilliantly connects these electric fields directly to their source charges.
It's so vital, it actually forms one of the four foundational Maxwell's equations of classical electrodynamics.
Plus, unlike Coulomb's law, Gauss's law is fully universal. It holds true even for moving charges.
So if this maps the electric universe, what unseen geometry governs magnetism? Well, keep exploring.